Hello again, class. Dr. Yeager here. We're continuing on with chapter 14 in our desert landform reading assignment. So, like I mentioned last time, right at the end, um, contrary to what a lot of us sort of intuitively think, when it comes to weathering and erosion in a desert or in a dry landscape, it's not necessarily wind that is the primary agent of weathering and erosion. It is, in fact, water. So the question is, well, how can it be water if it doesn't ever rain? Well, that's a good question. But like I explained last time, water is so much more powerful as an agent of erosion and weathering than wind that even if it only rains a day, 2 days, 3 days, whatever, um, that the amount of weathering and erosion that happens on that day or those 2 days or those 3 days is going to be exponentially greater than what would happen on a day when it doesn't rain and wind is doing all the work. Wind does have an effect on weathering and erosion, as we will talk about, but it just it just can't match the power of water. I mean, what think about what a stream can move in terms of stream competence, right? How big of a particle can a stream move as opposed to what the strongest wind can move. Um, Sometimes what I'll do in classes, I'll bring in a hair dryer and I'll bring in my leaf blower, and we'll go outside and we'll stack up some different size rocks, and the hair blower can blow small. It can blow sand, and it can blow small pebbles, and it might be able to move pieces of gravel just a little bit, but it can't move big particles. And that the leaf blower can obviously move the sand, and it can obviously move pebbles and gravel and things like that. And it might be able to get a big rock to move a little bit, maybe get it to turn over or something like that, but it can't blow it. And a leaf blower is, obviously got some fairly strong wind behind it. Uh, but a stream can move, a rock that big fairly easily and consistently. So water is, without a doubt, the most important external agent of erosion, even in places where it's relatively dry. Like I said last time, I will ask you that question on the upcoming test. So please make sure you've got that one firmly embedded in your brain because you'll see it again, I guarantee it. So why is water so important? Well, like we said last time, deserts are dominated by impermeable uh, land covers, which means that when it rains, very little water infiltrates down into the soil, and you get massive overland flow that happens very, very quickly and very, very intensely. The fact that there's less vegetation in deserts means that runoff water, that overland flow that's happening as sheet erosion and rill erosion and gully erosion, doesn't have anything in its way to slow it down. If there were plants, grasses, bushes, things like that were in the way of the water, it would slow it down. But since there's less vegetation, that water can move faster. And so what you see when you look at a desert landform or landscape like this is you see this clear uh, difference between erosion and deposition in different areas. And the areas where deposition is happening, deposition will clearly be the predominant landform maker, whereas where erosion is happening, erosion is clearly the dominant landform maker. It goes back to that idea of deserts being stark and abrupt that we talked about last time. I'm going to show you this picture here because it shows you the power of water as an erosive uh, agent here. So this white area is. I remember we talked in the last video about uh, basins of interior drainage and how in deserts basins of interior drainage will often fill up right after it rains, and then the water evaporates, and what this dry lake bed will sit there dry until the next time it rains. And I mentioned how all water has salt in it, and whenever the water evaporates, anything in the water gets left behind, and so all the salt gets left behind. And so some of these some of these dry lake beds end up being very, very salty. As a matter of fact, they are referred to as a salina. That is a desert landform that's called it's a dry lake bed that has a lot of salt in it. So it's called a salina. So whenever water would run out onto this onto this dry lake bed, when salt is exposed to water, it dissolves into the water. And so you can see water running out onto this salina, and you can see all the little rills where the water is running out onto, and they get smaller and smaller and smaller. And the changing color there is where you can see the brown is where the salt has been dissolved back into the water, so you can see the ground underneath it. It almost kind of looks like a leaf, right? Or it almost kind of looks like a reverse watershed. But in a watershed, the water would be running this way, right, and coming out this way. But in this case, the water is coming from this way and running out onto this salina bed, and it's distributing kind of out across the salina. It's a pretty cool picture. So in addition to salinas and things like that, there are some other unique things associated with water that happen in deserts. And one of those is called an exotic stream. And an exotic stream is kind of just like what it sounds. It's a stream. We all know what a stream is by this point in the semester. But an exotic stream is a stream that, I want to think about what the word exotic means. It's, if something is exotic, it's something that you don't see very often, or maybe something that comes from a different place that you're not used to. So an exotic stream is a stream that comes from another place and flows through a dry area. And that sort of makes sense. Most of the big streams that you think about in deserts, like the Colorado River or the Rio Grande or the Nile or streams like this, these streams are not streams that originate in the desert. It's hard to have a big river that originates in the desert because there's not very much rain. So these streams originate, their headwaters can be found in places where there is a lot of rain. And then as the stream moves down towards sea level, it moves through a dry area. So the Nile is an exotic stream. It flows through the Sahara Desert up here, but its headwaters, can be found high up in the mountains down nearer to the equator. The Colorado River is a great example. The Colorado River flows through Utah and Arizona and California through the deserts of the American Southwest, and it used to flow all the way to the Gulf of California through this dry desert. But the headwaters are high up in the Rocky Mountains, and so the water that flows through flows in the Colorado River actually formed from snow melt and glacier melt high up in the Rocky Mountains and rain that fell up there. These exotic streams, unlike other streams that get bigger as they flow on because more streams flow into them, or if you think about the Mississippi River, it gets bigger as it gets closer to the sea because other big rivers are flowing into it, right? Unlike those streams, an exotic stream actually gets smaller as it flows through as it moves along its course. Why does it get smaller? Well, because it gets smaller because there aren't that many streams in the desert as it is, so very few streams are flowing into the exotic stream as it moves along, and so it's not new water isn't added to the stream that way. As a stream flows through the desert, some of the water is going to evaporate, and so the stream gets smaller. And then as the stream flows through the desert, some of the water is going to be used by people who live in the desert, animals, obviously. So the stream is going to get smaller and smaller. In the case of the Colorado River, I mentioned that the Colorado River used to flow all the way to the Gulf of California. It doesn't reach the Gulf of California anymore because so much water is siphoned off by farmers, particularly in Arizona and California, using the water from the Colorado River to grow crops in the U.S. So most years the Colorado River doesn't even flow to the Mexican border anymore, um, which would probably make you pretty mad if you lived in Mexico and relied on that river historically. So in addition to exotic streams, there are things called ephemeral streams, and we have lots of those around here. Ephemeral streams are streams that have water in them. That have water in them generally right after it rains. They're going to be dry most of the time, but right after it rains, they're going to fill up with water, and a lot of times that water will be moving very quickly. And but once the rainfall has stopped, the stream will dry up. And so you probably can think of ephemeral streams that you might see around here, and you very may well find yourself standing in the middle of an ephemeral stream when you do your geography in my backyard project. There are lots and lots of those around here. And then I mentioned some of the desert lakes. These are often what would be of a the terminus of that basin of interior drainage. And so many of these are dry lake beds at the basin of an interior drainage. Water will flow in the streams and fill up whatever is at the bottom of that basin right after it rains, kind of like an ephemeral stream. But then when the rain stops, the water eventually evaporates and leaves behind a dry, flat lake bed. Those dry, flat lake beds in deserts are called playas. Yes, I know that that word means beach, and an interior dry lake bed doesn't mean beach, but that's what those are called. If there is a lot of salt associated with them, they're called a salina, like I mentioned before. Not all playas are salty. If the playa is salty, it's called a salina, and some of those basins have enough water flow to where the lakes are permanent, and those lakes do end up usually being fairly salty. So the Great Salt Lake or Provo Lake in Utah would be examples of that. Okay. All right, we're going to pause there. We will pick it up next time and start talking about desert landforms. And so we will see you then.